This is an example problem for orbital mechanics. What is the pull of gravity of a person on the surface of the Earth if the person's mass is 555 kilograms? Alright, so here's my strategy or strategery. Since the question asks for the pull of gravity, I'll use the universal gravity formula, given what I have, talking about the Earth and us sitting on the Earth. And we'll get the givens from our solar system data table, or I could just look them up on the internet. And because the person's on the surface of the Earth, I got to keep in mind that the distance between the Earth and the person is the radius of the Earth itself. Once I get my values in, and I know I'm using the universal law of universal gravity formula, then I'll just kind of plug and chug my answer. So let's take a look at the givens. I've got my universal gravitational constant. I've got the distance between the center of the Earth and myself, which happens to be the radius of the Earth. And I've got the mass of the Earth, all that from the table, or again, search it from the internet. Newton's law of universal gravity says that the force of attraction due to gravity is equal to g mm over r squared. So that's g, mass of the Earth, mass of the person, over the distance between them squared. So I'll plug in my numbers from the table, and I get a force of attraction of 544 newtons. But wait a minute, there's a way to check this problem. Because I'm talking about a person standing on the surface, and the pull of gravity, well, we call the pull of gravity the weight. And I have a special formula for the weight of a person on the surface of the Earth. That's W equals mg. So I can look at the mass of the person times g, 55.5 kilograms times 9.8 meters per second squared. And when I do the math, I get the same answer, 544 newtons. Pretty cool.